All right, before we dive into chapter 4, I want to do a quick review on interval notation. Okay. Excuse me. So I want to do a quick review on interval notation. Now, what you've used in the past, and you may remember interval notation. Okay, if I have something that looks like x is greater than 3. Okay, so here are our steps. We're going to look at the inequality. Okay, so the inequality has the greater than, less than, greater than or equal to, less than or equal to. We're going to plot it on a number line. We're going to write the answers from left to right. Oops, sorry. I just said right and wrote the wrong right. All right, so write answers from left to right. And then enclose with proper brackets. Okay, so enclose with proper brackets. So here's what I've got. This reads x is bigger than 3. There is an infinite number of solutions here because there's an infinite number of answers that are bigger than 3. Okay, so this is the old way that we did it. And remember that this way is greater than. Okay, if it reads less than, it'll look like an L, just kind of tilted over on the top. So this is less than or equal to, so it can be the same thing. This is greater than or equal to. So when I have this notation, first thing I look at the inequality and now I'm going to plop it on a number line. I'm interested in the number 3. And I'm interested in everything bigger than 3. So that is everything this direction. Okay, so I made my number line. Now, do you remember if you're supposed to use an open circle or a closed circle? So you're supposed to use an open circle. Now, why is that? Because technically you're saying this point works, this point works, this point works, this point works. All of these points work, which is why you shade it that way or make your arrow that way. But the actual value of 3 does not work. So 3.000000 with a million zeros after it, and then a 1. That works. Okay, but the actual value of 3 does not. So there's an infinite number of things that work. So now we're going to write our answers from left to right. So I'm going to start reading this thing. I don't have any answers over here. There's no answers. Well, my first place that I can start is a 3. You're like, but you just said we can't touch it. I understand. Hang on just a second. All right, so what's left? I'm going to keep going all the way out to positive infinity. Positive infinity. So I went to the right, so it's positive infinity. If I had gone to the left, it would be negative infinity. So I wrote my answers from left to right. So now I need to figure out what brackets to use. So if it is not equal to, so if it's just less than or just greater than, you're going to use parentheses, which in this class, I know that they are parentheses. I will call them soft brackets. Okay, they are soft brackets. On this one, if it includes the given number, which would be the or equal to, so this is less than or it is equal to, this is greater than or it is equal to, you will use hard brackets. Okay, now last little point, the infinities, negative infinity and positive infinity, those are concepts. Those are not numbers. Those are concepts. They are not numbers. Therefore, they can never be equal to. So the infinities will always use soft brackets. Infinities will always use soft brackets. All right, so come back down here. Am I allowed to set this equal to 3? No, because 3 is not bigger than 3. Okay, so he will get a soft bracket. So if it's an open circle, if it's one of these two things right here, he's going to get a soft bracket. So he starts, my pen just died. All right. So, all right. So he starts off with a soft bracket. So this soft bracket belongs to the 3. So the way I read that is start at 3, just don't touch it. Okay, start at 3, just don't touch it. So I'm starting at 3, but I'm actually truly starting at the very next number, but I can't represent it. So I have to say start at 3, just not at 3, start at the very next number. Okay, and then the infinities will always get soft brackets. So this is called interval notation. You're telling me the interval of numbers that work. All right, so let's try another one. We have x is less than or equal to -2. Okay, so make your number line. I am interested in the number -2. I am interested in everything smaller than -2. So I'm interested in everything this way. And then what would -2 get? He would get a filled in circle. Okay, so this would be an open circle like what we did here. We're going to do a filled in circle because I'm allowed to use that point. Okay. So this says everything up to -2, and you can touch the -2. Okay, because -2 is equal to -2. So now read your answers from left to right. Where does my answer start? Well, my answer starts somewhere -infinity. Keep reading it. Where does my answer end? My answer ends at -2. The infinities will always get a soft bracket. But -2, I'm allowed to use the -2. He has a filled in circle, or he has the or equal to. So he will get a hard bracket. And again, this bracket belongs here, this bracket belongs here, but together they should enclose it. So what happens if I have something in between? So let's do -1 is less than x, which is less than or equal to 4. Okay, so plot my number line. I'm interested in -1. I'm interested in 4. -1 would get an open circle. 4 would get a filled in circle. And x is between everything there. Okay, so read your answer from left to right. Reading, reading, reading. My answer starts at -1, but don't touch it. Okay, my answer ends at 4, and you can touch it. Okay, so everything between -1 and 4 is usable. There's an infinite number of numbers in there. But you're going to start at -1, just don't touch it, and you're going to end at 4, but you can also use the 4. All right, so one more type. Let's go off in different directions. Actually, a couple more types. All right, so if I have, and I'm just going to graph this. All right, let's just say that this is a 7 and this is a 12. He'll be an open circle. He'll be an open circle. And I'm going to go from this way to this way. All right, which means there's a gap. Okay, since you got 2 distinct answers, you got everything over here and you got everything over here, you're going to have 2 sets of brackets, which is okay. So start reading it from left to right. Where does your answer start? My answer starts in -infinity. Where does my answer end? It ends at 7. The infinities always get soft brackets, and this also means soft bracket. Well, I cannot use anything in here. Where does my answer pick back up? My answer picks back up at 12. I'm not allowed to touch it. And then where does it shoot off to? It goes up to positive infinity. Now, the technical symbol for and is a U, okay? But it's not a U. It doesn't have a little tail on it. Okay, this is called set notation. And this little U right here means everything in here and everything in here. Okay, everything in here and everything in here. So I'm not sure how the software is going to work. It may tell you to use a comma, or it may tell you to just type the word and. Okay, but this is the proper way to do it, and that symbol should be available to you when you're answering your homework. All right, so the last one is, what if I have all of this? Okay, well, where does your answer start? My answer starts somewhere in -infinity. Where does your answer end? Your answer ends somewhere in positive infinity. The infinities always get soft brackets. So what you have just learned is I'm allowed to use any number out there. Any number out there is fair game. And being a lazy math person, I would actually write this as all real numbers. So it's an R with double vertical bars. That tells me it's not an R, it's a symbol, and it means all real numbers. So again, I don't know if this will be available in your software, but it is slightly easier to use than writing this. Okay, always read it from left to right. So the next thing that we want to do is start figuring out why we're doing what we're doing. So why did I just show you all of this interval notation? So I want to talk about increasing. I want to talk about decreasing. And we want to talk about constant. Okay, so the easiest way for me to think of this is to explain airplanes. Okay, so if the issue is you can only read it from left to right. Okay, so if an airplane takes off and it goes up. Okay, so here's the runway and then it goes up and it takes off. If you read this from left to right, okay, the plane is increasing. Okay, what happens if I do this one? Well, this one is coming in like this. Okay, so as I read the red one from left to right, it's going down. So the red one is decreasing. Well, what if a plane has reached its cruising altitude? And I can't find my pens. All right, so if a plane has reached its cruising altitude, that means it is just padoodling along at 32,000 feet, whatever. So this is not going up or down. This is constant. Okay, this has a constant value. So we're going to look at equations and use calculus and determine when something is increasing or decreasing or constant. So an example that I want to give you is we are going, we are going to, I'm going to tell you the steps first. So if I just simply have y equals x squared minus 4, and I'm telling you right now that's a parabola, and he looks like this. All right, I want to know when is he increasing, when is he decreasing. So I can read the graph, and I can go from left to right. Well, right now that line, that curve is coming down, okay? And it bottoms out right there. Well, from then on out, that curve is now going up. Okay, so this way, read it from left to right. That arrow simply means it keeps going that direction. But if you read it from left to right, this side is coming down, so it's decreasing. If you keep reading it from left to right, this side is going up, so it's increasing. So here's your steps if you're given an equation. Take a derivative and set it equal to 0 and solve. Okay, and then we're going to use test points. So we'll have test points to determine if it's increasing or decreasing. So here's what we've got. We have an original equation of y equals x squared minus 4. I need to know where this is increasing, decreasing, or constant. So that tells me take a first derivative, which gives me 2x. My next step is set it equal to 0 and solve. So I need to get x by itself. So divide both sides by 2, which still gives me x equals 0. You now know your test point. Your test point is at 0. So here's what you do with the test point. Come back up to your derivative. Okay? Come back up to your derivative. You only go back up to your original function if you need a y coordinate. Come back up to your derivative and evaluate. So I know something happens at 0. So what's a nice number to the left of 0? Well, let's use negative 10. There's an infinite number of numbers to the left of 0. I'm using a friendly one. So I'm going to use negative 10. If I evaluate this at negative 10, 2 times negative 10 is negative. So that means it's decreasing. Okay, you got a negative answer, so your graph will be decreasing. Give me a nice friendly number after 0. So use, I don't care, use 100. There's an infinite number of points after 0, so use 100. All right, so 2 times 100 is positive. That means he is increasing in that direction. And if you remember, the graph looked like this. Okay, so it was coming down, it hit 0, and then it went back up. Okay, so where is it increasing? It starts increasing at 0. Okay, and then it's going to increase for the rest of its life. Remember, you're reading from right to left. Okay, where is it decreasing? Well, it's already decreasing. It's already decreasing. So it's decreasing from negative infinity all the way until it hits 0. Okay, now come back over to this part right here. When we have increasing, decreasing, and constant, you will only ever use soft brackets. Okay, you'll use parentheses. You will never use hard brackets with increasing, decreasing, and constant. So think about this. If I go to the airport and if I take a picture of an airplane, look at my little airplane. Is that airplane going up or is that airplane going down? You cannot tell unless you read the movement. You have to read the movement. So in saying that 1 point or a picture, okay, saying 1 point is going up or 1 point is going down, you can't have 1 point go up or down because that point is not going up or down. You have to tell me all of the points are going up or all of the points are going down. So come back here. That is why I did not use hard brackets with 0. You will never use a hard bracket when you're doing increasing, decreasing, and constant. And why is that? One more time. Because 0 cannot increase or decrease. If you say that, then you're telling me that point, and only that point, is going up or down. And that's impossible. So your bigger rule is never use hard brackets. So now we'll go practice in the next section.